Someone asked me this recently. Should I tell my son to become a plumber? It sounds like a practical question, a career question, the kind of thing you ask a guidance counselor or an economist. But it is not that question. What it is actually asking is this. Are there categories of human work that are structurally beyond what AI can do? Not because AI hasn't gotten there yet, but because the architecture it runs on makes certain things impossible in principle. That is a much more interesting question, and it has a real answer. But to get to the answer, we need to go back to 1945, to a mathematician named John von Neumann, and to a document that shaped every computer ever built, including the ones running ChatGPT. In 1945, John von Neumann described a computer architecture that became the foundation of modern computing. The idea was elegant in its simplicity. A central processing unit, a memory unit, a control unit that moves instructions from memory to the processor, one at a time in sequence. Fetch, decode, execute, write back. Fetch, decode, execute, write back. Every computer you have ever used, from the first mainframe to the latest GPU cluster running a large language model, is at its core a von Neumann machine. The chips are faster, the memory is larger, the parallelism is more sophisticated, but the fundamental logic is the same. And that logic has a property that is worth understanding. It is sequential. It is symbolic. It operates on representations of the world, not on the world itself. A von Neumann machine does not touch anything. It does not feel resistance. It does not get surprised by a pipe that is not where the blueprint said it would be. It processes symbols according to rules. This is not a criticism. It is an extraordinary capability. It is why we can model climate systems, sequence genomes, and generate language that sounds like a human being wrote it. But it is also a limit. Large language models are, in their name, language models. They operate on tokens, fragments of text, compressed representations of language. They are trained on an enormous amount of human-generated text, and they have learned, with remarkable precision, the statistical relationships between those tokens. When you ask a language model a question, it does not understand the question the way you understand it. It predicts the most likely continuation of the token sequence. It is extraordinarily good at this. Good enough that the output often looks like understanding. But there is something it does not have. Context. Not context in the narrow sense. Language models have plenty of that. They can hold long conversations, track references, maintain coherence across thousands of words. Context in the deeper sense. Embodied context. Situational context. The kind of context that comes from having a body that exists in a physical world, that experiences resistance and surprise and fatigue, and the specific smell of a basement that has been flooded for 3 days. The human brain does not think in language. Language is the output, the compressed, linearized version of a process that is massively parallel, deeply contextual, and inseparable from the body that runs it. When a plumber looks at a wall and says, the pipe is behind there and it's corroded, that judgment is not a language prediction. It is the result of thousands of hours of embodied experience, pattern recognition across multiple sensory channels, and a model of the physical world that is built from direct contact with it. A language model has read every plumbing manual ever written. It cannot do what the plumber just did.
Let me be precise about what I am claiming and what I am not. I am not saying that AI will never affect the trades. Robotics will change physical work. Diagnostic tools will change how problems are identified. Some tasks that plumbers currently do will be automated. What I am saying is something more specific. The core of skilled trade work is the navigation of physical reality in all its specificity, unpredictability, and resistance. Every building is different. Every pipe run is different. Every failure mode is different. The blueprint is a model of the world, and the world is always more complicated than the model. This is precisely the domain where the von Neumann architecture and the language models built on top of it hit a structural wall. Not a temporary wall. Not a wall that will fall when the models get bigger or the training data gets richer. A wall that is built into the substrate. Because the substrate operates on representations, and the trades operate on reality. This is not unique to plumbing. It applies to every domain where the work is fundamentally about navigating physical, embodied, situational complexity. Surgery, construction, agriculture, emergency response, care work. The jobs that are most exposed to AI replacement are the ones that are already symbolic, already linguistic, already operating on representations rather than reality. The spreadsheet, the memo, the legal brief, the code review. Not the pipe behind the wall. So, should you tell your son to become a plumber? The honest answer is, it depends on what you mean. If you mean, should he choose a path that is structurally protected from the current trajectory of AI development because it requires embodied intelligence that runs on a different substrate, then yes, that is a real argument. It is not a consolation prize. It is a genuine structural advantage. But the more important question is not plumber versus programmer. It is, do we understand what we are educating for? For a century, education has been optimizing for symbolic work, for the ability to process information, generate language, follow procedures, apply rules. These are exactly the capabilities that large language models are now extraordinarily good at. The capabilities that are structurally harder to replicate, embodied skill, contextual judgment, the ability to navigate physical reality in all its specificity, have been systematically undervalued, tracked into vocational programs, treated as a fallback for students who couldn't make it in the symbolic economy. That inversion is now being corrected by the market, not because anyone planned it, because the architecture has limits. The von Neumann machine is very good at being a von Neumann machine. It is not good at being a body in the world. So here is the one thing. The question is not which jobs will survive AI. The question is, what kind of intelligence are you building? Symbolic intelligence, the ability to process language, follow rules, generate representations, is now abundant and cheap. It will get cheaper. This is not a threat. It is a fact about the substrate. Embodied intelligence, the ability to navigate physical reality, to build skill through direct contact with the world, to develop judgment that cannot be compressed into a token sequence, is scarce. It will remain scarce. Not because it is mysterious, because it runs on a different architecture. The von Neumann machine changed the world. It will continue to change the world. But it has a limit that is written into its design. Your son or daughter does not have that limit. They have a body. They have proprioception. They have the ability to be surprised by a pipe that isn't where the blueprint said it would be, and to figure out what to do about it. That is not a consolation. That is a structural advantage. Tell them to build something with their hands. Tell them to learn how the world actually works, not how the model says it works. And tell them the machine is very good at language. It has never fixed a leak. AI does not change what the world is made of. It reveals what intelligence actually means. Fear not the AI. See you in the next episode.